Today we are going to do Chapter 12, Lesson 2. So last time we talked about what is energy. Today we're going to talk about energy conversions. And of course you'll need your directed reading 12.2, which is in your EN. Our objectives today are describe an energy conversion, give examples of energy conversions for the different forms of energy, explain how energy conversions make energy useful, and explain the role of machines in energy conversions. And this is one of the videos that you will come back and watch. So if you'll remember, kinetic energy is the energy of motion. It is in movement if it has kinetic energy. Potential energy is based on its position. So we can convert types of energy back and forth. And that's what a conversion is. It's a change from one form of energy to another form of energy. And any form of energy can change into any other form of energy. So here's an example. We have a skateboarder and a half pipe. And we're going to talk about the difference in his kinetic and his potential energy. So of course, if he's in motion, what kind of energy does he have? Kinetic energy. That's right. So as long as he's in motion, he has kinetic energy. So as the skateboarder travels up and down the half pipe, his energy changes back and forth between kinetic energy when he's moving and gravitational potential energy when he's not. So when he's up at the top, he has reached his potential energy maximum. That's all the energy that he's going to be able to get. And that's because gravity is going to pull him back down. Then he's going to start slowing down here, and then gravity's going to pull him back down. So he's got to get to going really fast to make sure that he has enough energy to get up the incline. We discussed elastic potential energy last time. Think about a rubber band. And the energy that you put into stretching that rubber band becomes elastic potential energy. It's sitting there waiting to be used. So it's stored up energy. When you let that rubber band go, it goes back to its original shape. It releases its stored up potential energy, and it becomes kinetic energy. The kinetic energy is due to the air particles moving as the propeller pushes on them. So think about that just for a second. You've got a rubber band. The further you pull that rubber band back, the more potential energy you're storing up. That would be elastic potential energy. When you let it go, kinetic energy. We get our energy from the food that we eat, and that's chemical energy. Then our bodies use this chemical energy to do what we need to do, to function. Plants are the same way, except they change light energy into the energy that they need. So the chemical energy in the food that you eat is changed into another kind of chemical energy that your body can use. Your body then uses that energy to give you kinetic energy so you can do everything that you need to do. Here's an example of photosynthesis. So from light energy to chemical energy. Chemical energy in the food that we eat, of course, comes from the sun's energy. And then the plants use that photosynthesis to convert light energy into chemical energy. So you can see all of these things work in unison to give the plant what it needs, and thereby giving us what we need. So why are energy conversions so important? Basically because we need them for everything that we do. Heating and cooling our homes, lighting our homes, watching TV, playing video games. I mean, the list goes on and on. So we have machines such as a hairdryer. They help convert electrical energy into energy that can work for you. So here are some conversions involving electrical energy. Not many people still use an alarm clock because most people use their cell phone. But it's still the same principle. You've got to charge that cell phone up, so it has to be plugged into electrical energy at some point or another. And then that will give you light and sound energy. So those are conversions that are being made. If you don't plug it up to electricity, whatever that machine is, has a battery, possibly. Any energy stored in a battery is chemical energy, and then that's converted to electrical energy. A light bulb is plugged into the wall. There's your electrical energy, converts it into light and thermal energy. Now, what is thermal energy? Think about a thermos. You put your drink in a thermos to keep it warm or to keep it cool. So thermal energy is heat energy. It's just another word for heat. A blender would be another example. You plug it in, there's your electrical energy, and then it converts to kinetic and to sound energy. So every type of energy can be converted to another type of energy. So a machine can make work easier for us by changing the size or direction, or both, of the force needed to do the work. Some machines allow you to use less force over a greater distance to do the same amount of work. Machines help you use energy by converting into the form that you need. So it takes whatever the energy is and it converts it into the form that we need to be able to operate that machine at that time. Okay, we've got one more slide, and this will be the end of lesson 12.2. So here's some energy conversions in a bicycle. And you will see this again on your EM page. So for this bike to start and keep moving, energy must somehow be transferred and converted. It's not going to just get up and go ride by itself. So the chemical energy in your body is converted into kinetic energy when you use your muscle fibers to contract and relax. That's when you're making it go round and round. Your legs transfer this kinetic energy to the pedals by pushing them around in a circle. The chain moves and transfers energy to the back wheel, which gets you moving, gets you going. And then the pedals transfer the kinetic energy to the gear wheel, which transfers kinetic energy to the chain. So a lot of different energy conversions are going on just from riding a bicycle. Okay, this concludes 12.2. The next time we will pick up with conservation of energy.